Welcome, viewers. Today, we have an intriguing example that will surely make you question the behavior of Python lists. Get ready for a mind-bending journey. We start with a simple expression that creates a nested list called nested_lists. It contains 3 inner lists, each filled with 3 ones. So far, so good, right? Let's print it and see the expected output. Boom. As predicted, we get a list containing 3 inner lists, each with 3 ones. Everything seems to be in order. But now, let's dive into something fascinating. What if we try to replace the first value of the first nested list with 2? Let's do it and print nested_lists again. Brace yourselves for the unexpected. Wait a minute. Something strange has happened. Instead of just the first value being replaced, the change has affected all the nested lists. How did that happen? The answer lies in the concept of mutability. You see, in this case, all 3 inner lists were referencing the same object. When we modified one of them, the change propagated to all the references, causing the surprising outcome. Don't take my word for it. Let's examine the proof. We'll print the references of each inner list using a handy loop. And there it is. The references for all 3 lists are the same. No wonder they all changed together. This phenomenon showcases the power and intricacies of mutable objects in Python. It's essential to understand these nuances to avoid unexpected results in your own code. So, sit tight and let's explore this fascinating world of mutability and object references in Python.